All right, here I'm just going to give you the chapter review for the test. Chapter 5, test review. All right, the main things, and this is this is a much easier chapter compared to the previous ones, because the most topics that are focused on are work, energy, and power, and then the conservation of energy as well. So the first thing that you need to know is about work. And you know, work is given by the product of force and displacement. So if an object is applied with a force in that direction, and if it's getting displaced in the same direction, then the work done is positive. And if the force is applied in the backward direction and the object is getting displaced forward, then the work done is negative. And a special case where force is applied at 90-degree angle, then there is no work done. So when the force and displacement are perpendicular to each other, there is no work done. Okay? So that is something that you have to be conscious about. Now, if the force is at an angle and the displacement is like this, then of course the work done is given by the equation FD cosine theta. Now, using this equation, you may have to know how to find the work. If I give you F, I give you D, and I give you the angle. So, for example, if I tell you force is 10 newtons and displacement is 5 meters, and if I tell you the angle is 60 degrees, so all you do is work done is equal to 10 times 5 times cosine 60, and you can work it out and the answer comes out to 25 joules. Okay, so this is one way of using this equation. I give you F, I give you D, you can find, I give you F, I give you D, and I give you the angle, you can find the W. Now what if I give you W and the D and the angle, can you find F? So all you do is just substitute then. So if I give you W, so W is equal to FD cosine theta. If I give you W and I give you D and I give you the angle, can you find F? Or I give you W, I give you F, and I give you the angle, can you find D? Or I give you W, I give you F, I give you D, can you find the angle theta? Like for example, if W is 100 joule, F is 10 newtons, and the displacement is equal to 5 meters. Oh no, 40. Okay. F is 40 newtons, displacement is 5 meters. So what is theta? What is theta? So all you have to do is, since W is equal to FD cosine theta, you substitute. 100 is equal to 40 times 5 times cosine theta. So which means 100 is equal to 200 cosine theta. So divide both sides by 200. If you divide both sides with 200, if you divide both sides with 200, I suppose it is coming in the view. All right, if you divide both sides with 200, so divide by 200, divide by 200, so you get cosine of the angle is 1 over 2. which is 0.5, and then you have to, you know how to find the angle from there. You have to do cosine inverse of 0.5. Cosine inverse of 0.5 with the calculator, and that should give you 60 degrees. You can double check on this on your calculator. Okay, so that is something that you should be capable of doing. And then we're talking about energy. So energy, there's a lot of light. Energy can be kinetic or potential. Kinetic energy is given by the equation half mv squared. Potential energy is of two types. Whatever we are interested in is, one is GPE and the other is EPE, elastic potential energy. GPE is given by the equation mgh or delta H, and EPE is given by the equation half kx squared. So you must know how to use these equations. Okay, if I give you certain quantities, can you find the kinetic energy? So let's focus on this equation. You must know how to find the kinetic energy if I give you mass and velocity. You must know how to find the mass if I give you the kinetic energy and the velocity. We have done questions like that in the classroom, so you can check your notes and find out how to do it. Again, if I give you the kinetic energy and if I give you the velocity, can you find the mass? Okay. So how do you do that? So if I give you, if kinetic energy is equal to 200 joules, and I give you also the velocity is 5 meters per second. So what is the mass? So what you do is just substitute into that equation. 200 is equal to half mass 5 squared. And then you know what to do. You just multiply both sides with 2 to get rid of the half. And now you have this, which is like 400 is equal to 25 mass. So you divide both sides with 25 later after that, and you can get mass equal to whatever. Okay, is it 16? Okay, 16 kilograms. And remember, whenever you have these questions, mass must be in kilograms, velocity must be in meters per second. Then your answer for kinetic energy will come out in joules. Okay. Now, what if I give you kinetic energy and I give you the mass? Then you have to find the velocity. So what do you do in that case is substitution again. If I give you the kinetic energy and the mass, how do you find the velocity? So just plug it in, and then you get v squared as what you want to find out. And then you take the square root of that to get the v. Okay, so just, I'll show you that also. So if kinetic energy is 200 joules, and if mass is whatever, is 10 kilograms, what is the velocity? So what do? Substitution. Kinetic energy is equal to half mass velocity square. 200 is equal to half times 10 times v squared. So half of 10 is 5. 200 divided by 5 is 40. So 40 is equal to v squared. So then you take the square root of 40 and get the v. Okay? So this is something that you need to know how to do it. More. This is something that you need to know how to do. All right. Coming on to this side, gravitational potential energy. Gravitational potential energy is mgh. So if something is at an elevation from the floor. So the floor is considered to be 0. No, the floor is considered to be 0 if you take the floor as a reference level, and if that is the height. So how do you find the GPE? You need mass, you need gravity, and you need height. So you have to multiply all three things. So GPE is equal to mass times gravity times height, wherever it is. So if you have all these three quantities, you can find this. Again, here also, if I give you the GPE and if I give you the mass, can you find the height? All right. Or if I give you the GPE and the height, can you find the mass? So these are things that you should be able to work out using the same equation. So let me give you this. If GPE is 100 joules and if mass is 5 kilograms, what is the height? So what you do is plug into that equation. 100 is equal to 5 times G is 9.8 and then times the height. So you get 100 is equal to 49 H. So now divide both sides with 49 and that will give you the H. Now all these kind of questions will require you to put just a minute into it. You don't have to spend more than that in order to get this answer. So you have to practice on this before you do the work. And whatever work you do, try to write it all down in your notes just for yourself. So therefore this is going to be 100 over 4.49. So it's something like 2 point something. So the height will be some 3 point something. Now potential energy can be also elastic potential energy. So if the question is about elastic potential, for elastic potential energy you don't need mass. You don't need gravity. You don't need the height. All you need is K and X. X stands for extension. K stands for force constant. So if you know the K and you know the X, you can figure out this. You don't need mass. You don't need gravity. Okay? So that is how we find. Now what is K? K is a force constant. So K can be found out, or K is connected by using the equation F is equal to Kx. That's our Hooke's law. So K is equal to F over X. So if I give you the force and the extension, you can find the K. Okay. Now remember, F must be in newtons, X must be in meters, not centimeters. So if X is given in centimeters, you have to change it over to meters. So if I give you extension is 2 centimeters, then you have to write extension as 0.02 meters. Then only you can use those equations. And K's unit is going to be Newton per meter. So if I'm going to use that equation, half kx squared, elastic potential energy is equal to half kx squared. Remember, the x must be squared. So let me just work it out with this. So x is this much. And if k is given to you also, if k is 50 Newton per meter, then you can find the EPE by just plugging it in. Half 50 times x squared, which is 0.02 squared. When you work all these things in an orderly fashion, you will definitely end up getting the proper answers. If you don't do in an orderly style, and if you try to jump into this equation and use your calculator straight away, that is not going to get you the answers. Alright, so you just work this out on your calculator and that will get you the answer in joules. Okay, so understand that concept. Alrighty, and let me see. Conservation of energy. Energy is conserved. It is not lost anywhere. It is not going anywhere. It is always moved from one form to another form. So if you're going to run a marathon, where are you getting all the energy from? Okay, so you're running a marathon, you're pushing yourself and getting yourself kinetic energy. Where is all that energy coming from? It's coming from the chemical energy. So likewise, there is always energy converted from one form to another form. Okay, so in a in a heater, in a room heater, the electrical energy is changing to heat energy, right? In a sound amplifier, electrical energy is changing to sound energy. So you can see how energy is conserved. Now, the conservation of energy that we are concerned more about in this particular thing is about potential energy and kinetic energy conversions. So if a ball drops from there and comes down here, it is losing GPE and gaining kinetic energy. So if I give you the height, then you should be able to, so the GPE that it has over here with reference to this level is mgh. But when it comes down here, it is going to get half from v squared. So it is going to hit the floor with this much kinetic energy. So mgh lost is equal to half from v squared gained. So mgh that is lost is translated to half mv squared. So if this ball is going to come down, so the mass of the ball is m. So the funniest thing is the mass of the ball is here and the mass of the ball is here. So basically those things will cut off, cancel off. That means whether it's a ball or a bowling ball or a brick, it doesn't matter. It's going to do the same thing. So GH is equal to half V squared. So multiply both sides with 2, so you get 2GH is equal to V squared. So with this equation, of course this equation is coming out of this expression. mgh is equal to half mv squared. Simplify to this. So you can actually figure out from here that if you drop something from a certain height, you can figure out the velocity. For instance, if I'm going to take a brick and drop it from a height of 10 meters, when it comes and lands here, how fast is it going to strike the ground? So you can actually plug everything in here. So v squared is equal to 2 times 9.8 times the height, 10 meters. So basically it's going to be what? 196? Yeah, 196 is v squared. So v will come out 14 meters per second. So it is going to strike the floor with 14 meters per second. Okay, so understand how to use that loss of energy and gain of kinetic energy concept. So you may be required to find the height, you may be required to find the velocity, whatever is required. The equation is mgh is equal to half mv squared. One is lost, one is gained. So if I give you the velocity, then you can find the height. If I give you the height, you can find the velocity. Okay. Take the g always as 9.8. And there is obviously one question where you need to read the question carefully, analyze the question, and then you must write down the answer, type the answer. Don't take a picture and try to attach it, because last time it actually, it normally causes problems. So type your answers in the space provided. Okay, that question, there's only one question that needs to be written down, and that is worth 4 points out of 30. There are total 30 points in this test. Okay, so make sure that you understand that part. Then you have the other concept, which is power. Power is work over time or energy over time. So power is equal to energy over time. If you cross multiply this, we get power times time is energy. So if I give you the power and if I give you the time, you can figure out the energy. All right? So if I'm going to say, if I'm going to use the connection. All right, so if power of a light bulb is 100 watts, and if the light bulb is operating for how much is the energy given out by the light bulb. So the energy that's given out by the light bulb, energy is power times time. So it's 100 times time. You can't keep time in hours. We need to convert hours to seconds, which is 3,600 seconds here. So times 3,600. So this will become 360000 joules. Okay, hope that is clear. What are the factors that affects the, what factors affect the gravitational potential energy? Gravitational potential energy is affected by these factors, m, g, and h, which means gravitational potential energy definitely depends on where you are. Are you on the moon or are you on the earth? That's important. And height is an important factor. Mass is another important factor. So these are three important factors here. For kinetic energy, it depends on mass and velocity only. So if I double the mass, you're going to have the kinetic energy doubled. If I double the velocity, then the kinetic energy is going to be double square, which is 4 times bigger. Okay, so we had a question in the homework about it. So when you double something, okay, so how many times is the kinetic energy going to be affected? For mass, it's just going to be affected as many times. So if the mass becomes 5 times bigger, kinetic energy is also 5 times bigger. But whatever happens to this, you're going to square it, and that's how you can connect it. All right. We did a couple of homework questions and all that in class. You should always go back to homework questions and then learn from it as to how to do it. They're all important. Okay, so all the best for your test. I don't think there's anything else I have to give you over here, but be careful with the units. Be careful with the units. If I give you something in grams, remember grams, you have to change it to kilograms. And so if I give you 250 grams, 250 grams is 0.250 kilograms. You have to change it to this. Okay? Same way, if I give you centimeters, then change it to meters. You cannot keep centimeters. For changing centimeters to meters, you divide by 100. And that is pretty much it. And do your best on the test. All right? Take care.